Hi, my name is Pradeep Sen, and I'm here to tell you about the UCSB Gaucho Game Lab and why it's one of the most unique programs we have here at UC Santa Barbara.
So in 2020, I started a new video game development program at UCSB called the Gaucho Game Lab. This is a 4-course sequence where students learn how to create some high-quality video games that are publicly released on major platforms such as Steam, the App Store, Google Play, and so on. The first course is an introduction to game development that is taught every spring, and the next 3 are advanced courses that are taught fall, winter, and spring of the subsequent year. And by the end of the program, students have learned to design and build some pretty sophisticated games. For example, this is our first major game, Arcana, which is now available on Steam. Arcana is a third-person action game where you play the role of a powerful wizard, and you get to decide what kind of spells to focus on, whether it's fire or arcane magic or even powerful frost spells. The more you play, the more powerful you become, until towards the end of the game, you're basically an ultra-powerful wizard. As you can see here, we're striving for a high-quality game with lots of depth and interesting characters and levels, until at the very end you're battling some pretty big monsters. So, that's Arcana. Take a look at it on Steam. So, in this video, I'm going to talk about 3 things. First of all, I'm going to talk about why the UCSB Gaucho Game Lab could be one of the most important programs for you here at UCSB. Second, I'm going to talk about the specifics of the game development curriculum, and finally talk about how you can be part of the program. Now, I'm sure many of you are already into video games, so I don't have to say much to sell you on this program. But there are probably many of you who are not that interested in video games, and so you're probably thinking, what's in it for me? Well, it turns out there's a lot in it for you. The program is transformative even for students who are not interested in a career in games or software development. So first, let's talk about the importance of our game development program. So let me start by asking a question. Why are you here at UCSB? In other words, what do you hope to learn while you're here? I'll argue that there are really 2 things that you'll want to get out of your time here at UCSB. The first is knowledge of technical concepts in ECE and CS and so on, and the second is the ability to apply these concepts to have a successful career. And you clearly need both. So let's talk about each of them in turn. First of all, in the next 4 years, you're going to learn a lot of cool things, right? You're going to learn math, science, programming, signal processing, whatever. A whole bunch of very interesting things. And it turns out that at UCSB, we do a really great job in teaching you all of these cool things. But the second thing is the ability to apply these concepts to have a successful career. After all, you'll probably want to get a job in industry at a major company, like the one shown here. So to apply these technical concepts, you need to know how to design actual products from start to finish, build complex systems, work on large teams, deal with diverse fields, and release products at a wide scale. Spoiler alert, no classes in ECE, CS, data science, or any other major, or any other engineering program anywhere for that matter, cover any of these things. In fact, we don't really teach this stuff at all in our program. And this is exactly why I created the game development program. So let's look at why these are so important in industry and how our game development program can help. So first of all, none of our current ECE and CS classes really focus on product design. And by product design, I mean starting with a blank slate and creating a product from scratch that has tremendous impact or generates considerable consumer interest. For example, how do you conceive of an idea for your product, pitch the idea to get support, test and iterate on potential designs, spec out and implement the work to deliver on time, conduct user testing and quality assurance to ensure a quality product. These are just a few of the things that you'll need to do product design. And as you know, it's a big part of engineering in industry because they're actually interested in designing actual products. At UCSB, the closest we come to this is the capstone sequence. However, the capstone projects are usually pitched by an external company or mentor and are very specific. So you don't usually conceive of the idea from scratch, but rather find a solution to a constrained problem that's given to you. On the other hand, product design is the key focus of our program. We give you a blank slate and ask you to develop a great game, and then walk you through all the stages of product design from start to finish. The second thing is building complex systems. Most engineering teams in industry work on extremely complex systems. Whether it's computer chips, rockets, cars, phones, these are all very sophisticated systems. On the other hand, systems that you build in most ECE and CS classes are fairly simple. Only a few hundred lines of code, a few hundred components, a few hundred hours of work. This is very typical in most classes, and this is nothing like projects in industry. So the standard ECECS curriculum offers almost no exposure to building complex real-world systems. On the other hand, video games are big, complex software systems. Our typical code bases are more than 10,000 lines long. For example, Arcana is over 12,000 lines of code, 300,000 files, and 36 gigabytes total. Furthermore, our curriculum is very practical, teaching you how to build real-world systems. And we teach you how to work your way through these massive systems with development tools like Agile development. Specifically, we use Scrum. We also teach you how to architect and design these complex systems in the proper way for scalability. This gets you ready to succeed in industry from day one. The third thing is working on large teams, because most of real-world engineering is done in teams of, let's say, 6 to 20 people. However, most projects in EC or CS are individual, or if they're group projects, they're usually small groups, no more than 5 people. Occasionally, Capstone will have a larger team, for example, the famous Hyperloop project we did, but those are relatively rare. So our students are missing experience in working in larger groups with proper management hierarchies like what happens in industry. As such, you don't really get exposed to stuff like how to manage others, communicating and working as a large team, collaborative version control systems and workflows like Git, gathering feedback and sharing control, and so on and so forth. However, in our advanced game development classes, we work on large team projects. For example, our current project has 15 people, 11 engineering students and 4 artists that are working together to produce our next major game, Odyssea. Students have actual roles and responsibilities, so we have a game designer, art director, level lead, character lead, and so on. And they're learning to coordinate and run meetings, resolve issues, communicate, and so on. This means that our students are getting teamwork experience that will be invaluable in the real world. The fourth thing is being able to work with folks from diverse fields. Because as the real-world workplaces become more diverse, employers are looking for engineers who can work with people from different fields. Unfortunately, most of our classes in EC and CS and the College of Engineering in general are very homogeneous. They're composed of almost entirely engineering students, or in closely related fields like physics, math, and so on. So there's not a lot of exposure to alternate ways of thinking, ideas, and so on from other disciplines. Unfortunately, our students mostly stay in this engineering comfort zone, which is unlike the real world. However, video games require the tight integration of solid engineering and high-quality art. As such, our classes cover not only the technical aspects of game development, but also aesthetics, art, and design. Students also learn to work with artists and use artistic tools to do high-quality artwork. And frankly, no other program in EC or CS does this, with the only possible exception in the College of Engineering being the MAT program. However, this is what the game dev program was designed to do, to integrate engineering with art like what happens in industry. And finally, it's important for companies to be able to release products at a wide scale. And unfortunately, typical EC or CS courses don't emphasize wide-scale public release, say stuff that will reach 100,000 or more people. Capstone projects, for example, have usually just a single customer, which is usually the sponsor company, but not a wide-scale release. So students don't usually learn how to create a marketing plan and bring a product to market. In industry, however, wide-scale release is obviously very common and critically important for the company's success. Furthermore, working on a project with wide-scale release requires a fundamentally different mindset. It is very different to work on a project with a wide-scale release than working on a project that no one will ever see. And let me give you an analogy of that. Let's say you're cooking just for yourself or cooking for a large dinner party. Do you approach both of these the same way? Of course not. So if you're cooking just for yourself, you might grab something out of the fridge and microwave it, and then eat it while you're watching TV. But if you're cooking for a large dinner party, you will take the time and gather all the ingredients, do everything really carefully, cook everything really well, and then serve it in a very elegant way. After all, you want to impress other people. So cooking just for yourself or for a large dinner party could not be more different in terms of how you approach the task, even though those involve the exact same thing, cooking. The same is true with project development. When you work on a project that you know will be seen by 100,000 people, you approach it in a very different way than a project that only perhaps the TA or maybe the professor, if you're lucky, will ever see. When you know your project will be widely released, you architect it differently, you write it differently, you test it differently, and the quality of your project goes way up. Our students are unfortunately missing this critical experience. Most projects you do at UCSB never see the light of day. But this is what the game program offers. Our games are designed to be released on major platforms like I described earlier. This not only teaches you how to release and market a product, it potentially gives you significant visibility as well. So in summary, our game dev program teaches you how to design actual products from start to finish, build complex systems, work on large teams like they do in industry, deal with a diverse set of fields, and release products at a wide scale. These are all extremely important in industry, but not covered in any other ECE or CS classes. So if you want a job in industry at a top company when you graduate, our game dev program will really help. But wait, maybe there's some of you saying, I'm a hardware person, not software, or I'm interested in XYZ, not video games. Why should I take your program? It doesn't matter. Real-world product experience is real-world product experience, regardless of what systems you're building. Games are just a means to an end for us. They give us something tangible we can build together that will generate tremendous public interest. Furthermore, all high-tech products have software in them. So if you're going into high-tech, you should learn good software engineering. And now let's go on to part 2 and talk about our game development curriculum. Like I mentioned earlier, our game development curriculum consists of 4 courses. First, there's an intro course, which is the first class of the sequence, where students learn the basics of video game development and make 4 or 5 simple games. The final project is to independently design and develop a fun game that provides around 15 minutes of play, and then the best games will be released for free through platforms like itch.io. Now, although this class sounds simple, it does require strong programming background, like CS 130A and 130B, and I'll talk more about this later. And then after the intro class, there's an advanced game development sequence that is open to students who get an A or above in ECE 184. The idea is to teach a dream team of students that did well in the intro class how to design and develop a major indie game title by working together as a team. The class assignments focus on various aspects of large-scale game development, and the objective is to prepare the students to develop a high-end game that will be developed independently, often through the capstone sequence that is taken concurrently with these courses. And this gets us to the Independent Advanced Game Project. The objective here is to create a high-end game like a major indie title that will provide more than 20 hours of fun gameplay and be released for sale on a major platform like Steam, Apple Store, or Google Play. I will provide the mentorship for the project, and it's structured like a real game company with a hierarchy of roles for every student. Like I mentioned earlier, this is often done as part of a senior capstone sequence, although many do it outside of that. And so please talk to me for more details on how you can approach this. So let's first talk about the intro class sequence. So the intro class focuses on the fundamentals of game design and development. The topics include introduction to games and game design, foundations of product design, principles of large-scale software engineering, because it is a software engineering course. We'll talk about game architectures, and we'll talk about game development frameworks, and specifically, we'll use the Unity tool. And in the last 8 weeks, students will independently design and develop a fun video game for public release. And in the past, we've released some pretty cool games. For example, this game's called Dragon Rider Counterattack by Nicholas Kwok. In this shoot-'em-up game, you're basically a dragon that's shooting a bunch of enemies that are coming at you. But because every game has to have some unique gameplay mechanic, in this particular game, Nick chose to have it go into 3D every so often, where you're actually fighting the enemies in 3D. And at some point, you're also fighting some larger bosses, as can be seen here. This game's called Into Hellfire by Rodney Lee. This third-person action game, you're basically crawling around dungeons, fighting these monsters, and trying to get all the way to the Dark Knight himself to fight him. Students can make any kind of game they want within some limited constraints. So for example, a lot of people make first-person shooters. This is Soldier 1 by Jason Dunn. This is a puzzle horror game where you have to walk around this creepy environment and solve puzzles. And some games target a younger audience. For example, in this game, you play the role of a trash picking up robot, and you have to tell the difference between recycling stuff and garbage. And so it's meant to teach younger kids the difference between the two. So the idea is to post these games on itch.io for free. So check out the page for our publishing partner, Red Athena Studio, to see these and more games that are available. So now let's talk about the Advanced Video Game Sequence and the Independent Advanced Video Game Project. So the Advanced Game Development Program offers 3 different tracks depending on your interests. First is the engineering track, for students who want to work as engineers in industry, building big, complex systems. Most of the students will fall into this category. Second is the business track, for students who want to go into management positions at high-tech companies, and so they still need the technical skills. And finally is the art track, for students who want to go into industrial art, and they're usually not engineering students. So most of the students that we get are usually falling into the first two categories, and it's still very important that they have strong technical skills to succeed in this. Each course in the sequence pushes all three tracks through the entire process of developing a complex indie game. In other words, we want people to understand how to do these different things and be successful in industry. So the sequence starts off with 185A, where students learn how to design a major indie game title and also produce the spec documents for the development of the game. The goal is to teach students how to design a game with unique mechanics so they can develop a fun, playable demo. And the topics include things like design and specification of AAA games, advanced mechanics design and development, team management and communication workflows, because a lot of what we're learning is learning how to work on a larger team, large-scale software version control, and agile software development methodologies. In particular, we use Scrum. So for example, for Neuromancer, the second major game title we're going to release, which was led by Mateo Vasquez, the game lead, in the first class we did a lot of character design, game design, and we built prototypes to try to understand the kind of game we were building. Then in the second class, we focus on the development of large-scale games. In other words, we're trying to teach students how to flesh out the demo into a full-scale game beta that offers more than 10 hours of fun play. And so we discuss level design and world building, advanced game development topics such as graphics, physics, networking, interactive storytelling, optimization and performance profiling, playtesting, and so on. So in Neuromancer, for that class, for example, we learned to develop a larger world for that game and built a more sophisticated prototype. And then in the third quarter, students learn how to launch and release the major game title. The objective is to teach students how to refine the beta they have into a shippable gold master and create and execute a marketing plan for a successful wide-scale product launch. So we talk about final product quality assurance, developing a marketing plan, game monetization analytics, and running a promotional campaign. These are all really critical to have a successful product launch. And so Neuromancer, for example, we just fleshed out the game, polished it up, had the final levels, until we finally had a game that was worthy of release. So this is a sneak peek at Neuromancer. We're going to try to release this game this summer. In this game, you're also a wizard, but unlike Arcana, you're not very powerful. In fact, you're a very weak wizard. You're just learning. And the only thing you can do is take over creatures' minds. So you're a Neuromancer and use those creatures to do stuff. So it's a puzzle adventure game where you are taking over these creatures, using them to fight your battles, but also to solve puzzles as you work your way through the game. So you're grabbing creatures and then you're using them to open doors, pull levers, and get through the levels of these dungeons. So that's Neuromancer. We're going to hopefully release it this summer. And like I said, the Arcana page is now up on Steam, and you can go there and you can wishlist it now. We'll be posting a demo shortly, and then soon after that, we're going to post the full version for you to download. And so wishlist it today because it really helps boost the profile on the storefront. And by the way, the students will get royalty from the sale of this game. Our current game we're working on is called Odyssea. It's a quest-based adventure based on Homer's The Odyssey. And we've got a great game director, Lizzie Green, who is really excited about the game, and we've made a lot of progress, and we can't wait to be showing you some sneak peeks of that really soon. Stay tuned for that. So finally, let's talk about how you can be part of our program. The first thing is to take the EC 184 Intro to Game Dev class that's taught every spring quarter. Most people take it junior year. And then the qualifying students who get an A or higher can then go on to the advanced game dev sequence, which is the following year, usually as a senior. However, you can start the program even earlier, like our current game lead for Odyssea, Lizzie Green, that I mentioned earlier. She's actually a sophomore. And so if you do that, you can actually work on several major game projects by the time you're done and have even more experience than the typical student. But you must have the right programming background for the courses to take our sequence. And this is due to the fact that we're building large software systems, so our program requires significant programming experience. So ECE 184 has the official prereqs of CS 130A and CS 130B, although we do accept equivalent courses. Basically, you need to know things like advanced data structures, linked lists, trees, heaps, and so on. Object-oriented programming in C++, so you need to be quite good at that. How to architect medium-sized systems with like 1,000 to 7,000 lines of code. Stuff like rendering systems, compilers, basic operating systems, things like that. You need to be able to not only build these, but debug them and get them to work. After all, we're trying to teach you how to build successful products, not how to code. So we really need you to have the right programming background for our courses. For CE and CS students, this is very easy to integrate into your existing study plan. This is the computer engineering sequence, and as you can see with the courses shown in red, it's a very simple modification to your existing grid to incorporate our program. So please talk to your undergraduate advisor about integrating this into your 4-year plan so that you can take these courses. However, if you're an EE student or from another major, things are a little trickier because you don't have that many programming courses. So we're working on getting a grid approved for EE students, but we probably can't do that for every major that is interested in our program. So in the meantime, we can petition students in with a portfolio showing your experience in software engineering and game development. You can contact me for more information, and it will post something in the Gaucho Game Lab website, but basically you can take some online courses, get the experience you need, and then you can take our course sequence. So the next steps, if you're interested in our game development program, is to start preparing for the program now. Even if you're a freshman, even if you're an incoming high school student, or even an early high school student, start preparing for the program now. We'll put lots of links and resources for you to get ready for our program when you get to college. And then talk to your undergraduate advisors to let them know that you want to be part of this program and how to fit it into your 4-year study plan. And you can also contact me directly if you have questions. In summary, if you want to eventually work and succeed in industry, you'll need to know a few critical things, specifically how to design actual products from start to finish, build complex systems, work on large teams, deal with diverse fields, and release products at a wide scale. As I mentioned earlier, these are not currently covered in our standard ECE and CS courses, which is why I designed this game dev program. So make sure you take these courses if you want to work in industry. But don't take my word for it. Check out this YouTube video to see what some current and former students say about our program, and learn why it could be the most important academic program for a successful career in high tech. So if you want more information, you can email me. You can also go to our Gaucho Game Lab webpage, which as of this recording is not live yet, but will be soon. You can sign up for news, alerts, and playtesting information. Or you can follow us on social media. And finally, download our games and play them. Have fun, and please, tell your friends. Thank you for your time, and I hope to see you in the Gaucho Game Lab.